Okay, a very good morning, children. As far as class ninth is concerned, this is our first live streaming which we are doing, and I hope you're all able to hear me out loud and clear. What you must all do is you must just give your attendance in the chat box so that I know how many of you attended the session. In today's class, we will be discussing about circular motion. In the previous videos, we've learned what is uniform motion, what is non-uniform motion. We also did some very simple numericals based on, based on distance and displacement, and we've also talked about the three equations of motion. And now this is the last portion of the chapter, which is circular motion. Okay, so I gave you a brief background of what is a circular motion and how do we enter into a circular motion. So if you look at this diagram, look at this first the rectangle onto your left. Now suppose this yellow arrow actually shows my position, my initial position, and if I start my journey here, so initially I go north, which is I go like this, I go north up like this, and I reach my first point, here, and at this first point I change my direction. So how do I change my direction? I travel like this, I travel towards the east like this. Then again, after reaching point number 2, I again change my direction and I go south again like this, and I reach the point 3, right? And at this point again, once again, one more time I change my direction and I go west like this. So how many times in the first in this first figure have I changed my direction? I have changed my direction 3 times. One is here, the second one was here, and the third time that I changed my direction is here. So for a rectangle, or suppose I change my direction 3 times, it becomes a rectangle. So to make a rectangle, if I'm traveling, I have to change my direction 3 times, right? Now look at this, the hexagon. Suppose if I start my journey here, right? So I'm traveling straight. At the first point, I change my direction. So I travel like this. Then the second time I change my direction, I go like this. Third time I change my direction. Fourth time again. Fifth time again. So after 5 times when I change my direction, I reach at the same original position from where I started my journey. So if I change my direction 5 times, what kind of a figure am I going to get? I'm going to get a hexagon, right? Now let's see. So this was 3 times the rectangle, then 5 times. Let's say if I want to change my direction more number of times. So what I will do is, suppose let's say if I start my journey here. Now look at this octagon, right? If I start my journey here and I change my direction 7 times, what happens? I kind of get a shape which is much close to a circle. Now look at this. This is nowhere close to a circle, the rectangle. Then hexagon is slightly, it is coming close to being a circle. Then what about octagonal? Octagonal shape is even more closer to becoming a circle. So if I change my direction more number of times, it becomes an octagon. Okay. So now in the case of circle, what do you expect? What should happen? In the case of a circle, what a person should do is, in order to make a circle, he should change his direction more number of times. Maybe every second he should change his direction, right? So if I change my direction more number of times, I will end up traveling in a circle, right? So these are some of the closed track, okay, that we are looking at. Now, why are we looking at a closed track? Because we want to study circular motion. Now, look what happens in a circular motion. So, look at these arrows. So, we just learned that in a circle, every second the body is changing the direction. How is the body changing the direction? Let's learn that first. Now, suppose the body is here at this blue circle, right? This blue point that you see here. Now, at this point, the body was actually trying to travel like this, tangent to the circle, but as it is traveling in this direction, suddenly it changes its direction. So now the body travels like this. See this red arrow, okay, like this, again tangent to the circle. Now again, when it comes here at this point, see, every point it is trying to travel tangent to the circle, right? It is not actually traveling in a circle. Every point, see, look at this point, the southmost point here, the blue point here, it is trying to travel tangent to the circle. But every time it tries traveling tangent to the circle, what happens? It switches its direction, it changes its direction. Then again one more tangent here, then again it changes its direction, then one more tangent here. So all this while he is traveling tangent to the circle, right? So and when every second the velocity is changing, so I just told you what is the difference between speed and velocity. If the let's say the direction is changing every second, what is changing? If the direction is changing, the velocity is changing, right? So in a circle, it is the velocity which keeps changing every second, and whenever there is a change in the velocity, we say that there is some acceleration which is involved. So that's why we say any body which is traveling in a circular motion actually has some kind of acceleration, uniform acceleration. Why uniform acceleration? Okay, you understood that part. Whenever there is a change in the velocity, there is going to be some acceleration, right? And why do we say that it's a uniform acceleration? Because every time the velocity is changing by the same amount, right? The velocity is changing, the direction is changing the same way every second. So that's why this kind of motion is known as uniformly accelerated circular motion. So the question that will be asked to you will be is circular motion, what kind of a circular motion is a circular motion? So you would say a circular motion is a uniformly accelerated motion, right? And why is it uniformly accelerated? Because the velocity is changing every minute, because the velocity is changing every second, right? That's why it is uniformly accelerated motion. Now here once again I've tried to show you what this with the help of this diagram as to how the acceleration is changing. Look at this point, the northmost point, the arrow which is shown in green, this is how the velocity, this depicts the velocity of the body, right? This again, the green, all the green arrows here depicts the velocity of the body. Now the yellow arrow, okay, this arrow actually shows the acceleration of the body. So while the body is trying to travel tangent to a circle, where is the acceleration acting? In which direction is the acceleration acting? The acceleration is acting towards the center, right? This is very important here. So acceleration has a constant magnitude, but it has different direction every time. Here the acceleration is downwards, here the acceleration is like this to upwards, here the acceleration is diagonal like this. So the direction of the acceleration is changing, but the magnitude of the acceleration will remain same, correct? And the acceleration will always be perpendicular to the velocity. This point over here is very, very important. You all should make a very good note of this point, right? So now suppose let's experiment something like this. Suppose you take a thread and attach a ball at the end of the thread, and you try and rotate that thread around just like a circle as shown in this figure. Now what will happen if you leave the thread? In which direction is the thread going to go, right? If some of you are thinking that the thread is going to go like any direction, it is incorrect. The ball is going to travel anywhere you leave the ball. Suppose you leave the ball here, right? The ball is going to travel tangent to that circular motion. If you leave the ball here, then the ball is going to travel tangent like as shown in the figure. Suppose if you leave the ball here, then it is going to travel tangent. So whichever direction you leave the thread, the ball is going to travel tangent to the circular motion. And what does that tangent depicts? The tangent shows the velocity of the object. And in which direction is the acceleration? The acceleration is going to be perpendicular to the velocity towards the center. And the acceleration will have a constant value, but it will have different direction, you know. So this is very important. So this is one example of how the acceleration can be uniform and the velocity, but still the velocity can be different, right? So now we have come to the end of the chapter, and there are a few numericals that we are going to now discuss. The first one is has object, in this case, just a second. Yeah. So let's say we don't need this. Now the question over here, you can I have shown you different tracks here, right? This boy starts from here. This is the start line. He takes a circle and comes back to the finish line. So is there any distance or is there any displacement? It means you're going to talk about what is the distance and what is the displacement. And can the displacement ever be zero? The question is, can the displacement, can it have zero displacement? Can you have zero displacement? Yes, you can have zero displacement. When all can you have zero displacement? The diagrams are here. Suppose if a boy starts from the start line here and he takes a circle and comes back to the same start line again. You know, this is the finish line. So if the start point and finish point is the same, which means displacement is zero, because we studied what is displacement. Displacement is the difference between the final and the initial point. Is there any difference between the final and the initial point? No, because he started from the same point and he ended up standing at the same point. So in this case, the displacement is zero. Look at this. The second rectangle here, the boy starts from the point A, travels up like B, then C, then D, and then back to A. Now, if I ask you here, what is the distance? So you would say the total distance that the boy has traveled here is 3 plus 5 plus 3 plus 5, which makes 16 meters. So he has traveled 16 meters here. So what is that 16 meters? 16 meters is the distance that he has traveled. But what is the displacement? The displacement of the boy is zero, because his final position and his initial position is the same. There is no change in the final and initial position. Okay. And the last example is also the same. Suppose if this bus travels like this from A to B and then travels back to A, so which means the bus has traveled some distance, some specific distance. But what about the displacement? The displacement is going to be zero, because the bus has started from a point A and gone back, and it has come back, you know, to the same point A. So that's why the displacement is going to be zero, right? So let's look at the next question here. Now these are some of the your exercise and in-text questions that I have taken so that you are able to understand. Once again, if you have not written your name and your class and section, please put down in the chat box so that I know who all attended the class. Okay, so let's start again. The second question is, the farmer moves along a boundary of a square field of side 10 meters in 40 seconds. So let's say there's a farmer, he starts from this point and he goes around this boundary something like this, okay, from A to B to C, D and back, right? So each side of the square field is about 10 meters and he travels a boundary of a square field in 40 seconds. Means he travels how much distance? He basically is traveling 40 meters. He's traveling 40 meters in how many seconds he's traveling? He's traveling in along a boundary of a square field, okay, in 40 seconds, right? So the complete boundary, 10 into 4 is 40 in 40 seconds, right? Now he is asking what will be the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds. So he is asking, after 2 minutes 20 seconds, what will be his position and what will be the displacement from the initial point. So first what you got to calculate is, where will he be after 2 minutes 20 seconds, right? So 40 40 meters he travels in 40 seconds. So 2 minutes 20 seconds. Where will he be? So first you've got to calculate what is the time. So the time is, see, 2 minutes, look at this, 2 minutes 20 seconds. What is 2 minutes 20 seconds? 2 minutes 20 seconds is 140 seconds total. Correct? Now you know that one round is how much? One round is 40 meters, right? And he takes one round in 40 seconds. So how many rounds will he take in that 140 seconds? Right? One round in 40 seconds. So how many rounds in 140 seconds? So how many rounds will he take? It will be 140 divided by 40, which will give you 3.5 turns. So he takes 3 turns, right? He takes 3 turns. So 3 turns means 3.5, sorry. He will take 3.5 turns. So after 3.5 turns, where will he be? He will start from here. So 1 turn complete, then 2 turn complete, then 3 turns will complete, and 1 more half turn. So half turn he will be at position C. So initial position was A, but now the final position is going to be C. So he's asking what is the displacement. Look at this. What is the magnitude of displacement here? The magnitude of displacement means what is going to be the displacement. So you have to basically find the difference between A and C. How will you calculate the distance, the difference between A and C? You know the two sides. This is 10 centimeter DC, and this is also AD is also 10 centimeter. So you will use Pythagoras theorem and you will calculate this side, okay, AC, correct? So it will be 10 square plus 10 square and under root of that total, which will give you 10 into root of 2 meters. So is it simple? You just have to calculate where will he be after 2 minutes 20 seconds. Okay, and then calculate the difference between the final and the initial point, right? Now look at the next question here. Under what conditions of the magnitude of the average velocity under what conditions is the magnitude of average velocity of an object be equal to its average speed? So the question that he is asking you is, what will be the conditions under which your average velocity and your average speed are going to be the same? When will they be equal? So first understand what is average velocity and what is average speed. Average velocity means there is displacement involved. Average speed means there is distance involved, right? So when will they be same? You can see here the total time remains the same, right? But in one case the distance is divided, in the other case the displacement is divided, right? So now when will these two be the same? Suppose you take this first example, a boy is traveling like this in straight line. So if he travels from this one end to the other end, both the distance and displacement are going to be the same. There is no difference. So which means both the velocity, average velocity and average speed are also going to be the same, right? But so in the first case both will be same, right? Now let's understand what will happen if the boy starts from one end, goes to the other end here, and then comes back, returns back to the same point. Means the boy has changed his direction. What happens when you change the direction? Is the distance and displacement going to be the same? No, but it will be different. In this case the displacement is 0 because he started from the initial point and again came back to the same point, right? So in this case the displacement will be 0. So now if you substitute the value of displacement here, it is going to be 0. But what will be the distance when the boy travels, like he goes 100 with some distance, let's say 100 meters it goes and comes back? So distance will be 200 meters, right? So distance will be 200 meters here, correct? So the distance will be 200 upon the total time. So whenever you change your direction, your average speed and average velocity will be different, right? Okay, here there's a small mistake which I will have to edit. Here this is not meters per second, but this is just meters. This is just the distance that I'm trying to show here, okay? So you all can edit that here, right? So these are the meters. So when will both average velocity and average speed be different? It is very important for you to understand. Only when the distance and displacement is same. When can that be? only when a body is traveling in the same direction. So the answer to this question is when the object travels in straight line. When the object travels in straight line, only in that case, when he's not changing his direction, that means both average velocity and average speed are going to be the same. Correct? Now, next question. What does the path of an object looks like when it is in uniform motion? So all of you know, it's very easy. How is the graph of a uniform motion looks like? It is always a straight line like this, slant line like this, right? Means equal distances in equal intervals of time. So I hope this requires no explanation. So now we move on to the next question. Okay, look at this. During an experiment, a signal from a spaceship reached the ground station in 5 minutes, right? So there's a signal which reaches in 5 minutes. So the time is given. Remember that anytime you're given a numerical, it's very, very important for you to jot down the given data, because if you're given data, if you are able to note the given data correctly, half of your problems are solved, you know, while during the physics numericals, right? So neatly write down the given data. So what is the given data in this case? The time is given to us, which is 5 minutes. Okay, what else is given? At what was the distance of the spaceship from the ground? The signal travels at a speed of light, which is 3 into 10 to the power of 8. So this is 3 into 10 to the power of 8. Okay, this is 10 to the power. So speed is given to you and time is given to you. You have to just calculate the distance. So it is very simple. There is no acceleration involved, nothing is involved. So what will you do is, you will simply apply the formula speed is equal to distance upon time and substitute the values and calculate the distance. So this is absolutely simple because I have not given you any acceleration, nothing is involved, there is no change in the velocity. Okay, so this is pretty clear. Now next is, what can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis, right? So which means there are two kinds of graph which can have straight line. This is also a straight line, means slanting line but straight, right? This also can be a straight line, but he specified that the line has to be parallel to the x-axis. He specified that the line has to be parallel to the x-axis, right? So which is the correct graph? The second one is the correct graph. Now what can you say about what does this graph tells you? And I told you how to read the graph. How do you read a graph? Suppose this is 0 time, that is the time when the object has just started its journey. Now let's say after 1 hour, what is the distance? Some distance, let's say this is the point, so some distance, let's say 2 kilometers it has traveled. Let's say after 2 hours, go up, touch the line, come to the y-axis, how much of distance has it traveled? Again the same, right? Now the same, which is 2 kilometers, again after 6 hours. So that means wherever you go on this line, the time is changing. After 6 hours, after 2 hours, after 8 hours, after 10 hours, this is the time which is changing. But suppose after 8 hours you go up and you touch this line, right? Where do you reach? You reach the same distance. That means the body isn't traveling at all. The body is stationary. So this graph tells us that the body is stationary, right? What does this graph tells you? This graph tells you that the body is continuously moving, because after 5 seconds, it is how much distance is it traveling? 10 meters or kilometers. After 10 seconds or 10 hours, it has traveled 20. Means every point the distance are changing. So this body is traveling, but this body is stationary. So suppose if someone asks you to draw a distance time graph for a body which is stationary, which is parked. Suppose your car is parked, you know, in your garage. So draw a distance time graph. So how would you draw the distance time graph? Something like this. If the car is parked, then this horizontal line will not be here. This horizontal line will be exactly on the x-axis, right? Suppose you have traveled to certain distance and then you stopped, then this may be this line. You can represent it by using this line also, right? So this line represents, the graph on the right represents a graph of a stationary object, correct? Now, there's another graph that I'm showing you. The graph is the same, but the only difference is that right now I'm showing you speed on the y-axis and time on the x-axis. Now, how do you read this? What does this graph tells you? These graphs are very important. Please make a good note of all these graphs and what do they talk about. So let's say if I take a point here on the graph, somewhere on the x-axis, let's say after 1 hour. So after 1 hour, let's go up and touch this line, and then come to the y-axis. Suppose this speed is 10 meters per second. So after 1 hour, the body is traveling at 10 meters per second. Let's say after 2 hours, so let's say this point is where my cursor is 2 hours. So after 2 hours, again I go up like this, I touch the same line, then I read the speed here. What is the speed here? Let's say, for example, the speed written over here is 10 meters per second. So which means after 1 hour also the body was traveling with 10 meters per second. After 2 hours also the body is traveling with 10 meters per second. After 3 hours also, if I go up, the body is still traveling with the same speed. Which means what? Now the body is not changing its speed. The speed of the body remains constant. Which means again it's a uniform motion. It's a uniform motion. The body is traveling with the same speed. Right? So this is what this graph talks about. So you have to be very careful what is on the y-axis and what is on the x-axis, and accordingly read the graph. Okay. Now look at this. Now what is the quantity which is measured by the area occupied below the velocity time graph? I mean to ask you, suppose now here you see velocity on the y-axis and time on the x-axis, right? And I have drawn a graph. The graph is OABC, correct? Now the question is, what is the quantity which is under this velocity time graph? Suppose if this is the shaded portion I have shown you. The shaded portion is this, the one in the yellow color. So if I calculate the area, I told you previously also, if you calculate the area for a velocity time graph, you will be getting the distance, or we can say displacement here. Okay, this is exactly the same thing we did when we were graphically deriving the relationships between the three terms: velocity, time and position. What did we do? We calculated the area under the velocity time graph, and when we calculated the area, what did we get? We get distance. So here also the answer is we will get distance. So you all can probably write we will get distance. Sometimes the question can be what will be the unit of the quantity? The question can be what is the unit of the quantity which is measured by the area occupied. So unit can also be asked. So the quantity is distance and the unit can be meters, right? The unit will be meters. Now next, look at this question again. This seems to be quite easy for you. I told you please jot down the given data first. Now a bus decreases its speed from 80 kilometers per hour to 60 kilometers per hour. So what is given over here? Two speeds are given, right? So one you can mention as u, okay, which is the initial speed. So what is the initial speed here? 80 kilometers per hour, okay, and then is v. So what is v is the final velocity, because it is clearly saying the bus has changed its speed from 80, it has come down to 60. So the final velocity is going to be 60 kilometers per hour. Okay, what else is given? Time is also given. So you can write the time is given as 5 seconds. So three things are given to you. You are supposed to calculate acceleration. And we have done one more important thing that I would like to tell you here is, remember that if the speeds are in kilometers per hour, your time has to be, your time has to be in hours, right? But or what you can do is, if your time is in seconds, then you have to convert kilometers per hour into meters per second. Okay, how would you convert kilometers per hour into meters per second? You have already studied in your class 7. Please brush up these conversions, because these are really important. Okay, how would you do that? 1 kilometer is equal to 1000 meters, and how will you convert 1 hour into seconds? 60 into 60. So 1000 upon 60 into 60 is what you're going to do it, right? So the formula is very easy. What is the formula for acceleration? We know that formula for acceleration is this: v is equal to u plus at. From this is the first equation of motion that we did. From this equation you can calculate your acceleration. See, I have converted this into meters per second. So we get 22.22 and 16.67. And when we substitute, so you know v, you know u, you also know your time. What you have to calculate is your acceleration. So acceleration is going to be minus 1.11 meters per second square. These units are very important, right? Look at this. Velocity is meters per second. But what is acceleration? Meters per second square. Okay. And what does this minus sign tells you? The minus sign tells you that it is deceleration. The body has reduced its speed, right? Is it so? Is the case similar? Yes. The body was initially traveling at 80. Now the body is now traveling at 60. So body has come down on its speed from 80 to 60, right? So probably how did the driver reduce the speed? He probably must have applied brakes, and that's why he had decelerated the body. It is also called as retardation. Retardation means reduction in the speed, right? So this was too easy. Now next one is a train starting from a railway station and moving with a uniform acceleration attains a speed of 40 kilometers per hour, right? This kilometers per hour minus 1 that I have written over here is actually kilometer per hour. It is divided by hour. That's why it is minus 1, right? So what is, again, just write down the given data. You know that a train is starting from a railway station and it attains a speed of 40 kilometers per hour, right? So the final speed that it attains is 40 meters per, this is, you can write, this can be, this should be 40 kilometers per hour, not 40 meters per second. Okay, so this is kilometers per hour. And you know the time is also given. You have to calculate the acceleration. Now, one more thing there. How can you calculate the acceleration? You know the formula. What is the formula for acceleration? V is equal to u plus at. This is the formula. Now, how many variables are there? First is v, second is u, third is a, and fourth one is t. So I told you, if you have to calculate any one variable, you must know. So how many? There are 4 variables. You should know 3 variables. Then only you can calculate the 4th variable, right? So do you know 3 variables? Yes, you know v, you know t. Do you know u? Yes, you know u. What is u? In this case, it is not directly given, but it is indirectly given as u will be equal to 0. Why? Because look at this, the train starting from a railway station. The train is just starting, which means it was at rest, now it starts. So which means the initial velocity has to be 0. Sometimes you have to just read between the lines, right? So now you know u is 0, v is basically 40, your time is t. Now, but then time is given in minutes. So this minutes, I told you, everything has to be in kilometers per hour. Meters per second, or time has to be in seconds. Get it in one unit. Suppose if it is in kilometers per hour, you have to change your 10 minutes also in hour, right? So why would you complicate the situation? So what you should do is convert this kilometers per hour into meters per second. Also convert your time into seconds. Okay, so remember, time has to be in seconds, right? Distance will be in meters. Then your speed will be in meters per second. Keep it simple, right? So this is how. So look at this. Initial speed is 0. Final speed is 40 kilometers per hour. How will you convert this kilometers per hour into meters per second? You will multiply it by 1000 and divide it by 3600. So you will get 100 upon 9 meters per second square, right? And then what is the time given? 600 seconds. So now it is very simple. Just substitute the values in the formula and you will get 0.018 meters per second here. So this is the acceleration. So again it is positive acceleration. Why positive? Because the train was initially at rest and the train picked up some speed. So from rest it picked up some speed, which means the acceleration has to be positive, right? Okay, let's move ahead and understand this question. Again, this question is going to make your ideas clear about what is average speed and velocity in case there are still some hurdles that you're facing. Okay, Joseph jogs from one end A to the other end of a straight 300 meter road in 2 minutes 50 seconds and turns around and jogs 100 meter back to point C in another 1 minute, right? So I'll first make you understand the situation. There's a person, Joseph. He starts from A, he travels till the point B and again turns back and then stops somewhere here. Means he's traveling till the point C, which is somewhere, somewhere maybe midway or may not be midway, right? It's definitely not midway, it is just 1/3. So this distance from A to B is 300 meters, which he covers it in 2 minutes 50 seconds, right? And when he turns back, he covers 100 more meters in how many minutes? 1 minute. Simple. So the situation is clear to all of you. Now the question is, what are Joseph's average speed and average velocities in jogging? Means you have to calculate both average speed also and average velocities also while he is jogging, right? And you have to calculate this for both the paths. One is from A to B, another one is from A to C. So first what we are going to do is, we are going to calculate average speed now. Average speed for both, average speed for A to B and average speed for A to C. So let's write the formula for average speed. The formula is total distance covered upon total time. Now first let us consider the distance A to B. What happens from A to B? First tell me what is the total distance that he covers while traveling from A to B. The total distance that he covers while traveling from A to B is nothing but 300, right? And what is the total time? He covers it in 2 minutes 50 seconds, which I have converted into seconds, which is total 170 seconds. Look at this, 170 seconds. Okay, so total distance is 300, total time is 70 seconds. If I divide them, I will get my average speed, which is from A to B. Now let's see, if Joseph travels from A to C, means he goes from A to B, turns back and comes to C. Now what is going to be the average speed? So average speed again will be total distance upon total time, but in this case total distance will be different. Total distance will be 300 like this and one more 100. So the total distance will become 400 here, correct? It's going to become 400. 100 plus 300. Well, 300 here plus 100, right? And what is going to be the total time? Total time is going to be this 2 minutes 50 seconds plus 1 more minute. So it will be 3 minutes 15 seconds total time, which I have converted into seconds. So 3 minutes 50 seconds will make 230 seconds, correct? So if I divide them, I will get average speed. Okay, so look at the average speed. So this is how we calculate average speed. Simply divide total distance upon total time, correct? Now let's see what will happen to total velocity. Total velocity, the formula again is displacement upon total time taken. Now understand, recall the concept of displacement. What is displacement? Displacement is the difference between the final and the initial point. Now while when Joseph was traveling from A to B, what is going to be the total displacement from A? He stops at B. So displacement will be 300 only. What will be the total time? Total time will be 170 only, because he takes 2 minutes 15 seconds, which is 170 seconds. Correct? So if you divide, you will get 1.76 seconds, meters per second. That is the average velocity. But look at the second case here. When Joseph is traveling from A to C, which means he starts from A, goes to B, comes back to C. Now he stops at C. So now what is the displacement? Displacement is the difference between the final and the initial point. So what is the distance between these 2 points A and C? What is the distance between these 2 points? 200. 300 minus 100 is 200. So it will be 200. And what will be the total time? Total time is going to be 2 minutes 50 seconds. Then 1 more minute when he comes back to C. So it is going to be 3 minutes 15 seconds only. So here displacement is different, but time will remain the same. Now if you divide this, you will get 0.869 meters per second square. Right? Now if I show you the results together, both the results, look at this. From A to B, which is a straight distance, he is not turning, from A to B, average speed is 1.76, average velocity is also 1.76 that we calculated. So both are same, right? But look at what happens when he travels from A to C. A to C, when he is traveling, he is changing his direction in between. At B point, he is turning back. So look at the average speed and average velocity. Are they same? No, they are different. Why are they different? Because he has changed his velocity. Correct? But what happens when he travels straight path, on a straight path? He doesn't change his direction. Both average speed and average velocity are going to be the same. This is what we discussed in one of the questions. If I have to tell you in this question, this is what we discussed. Only when the object travels in straight line, the magnitude of average velocity and average speed is going to be same. And this is what we are learning here also. Both the average speed and average velocity are going to be the same if the object is traveling in the same direction and not changing his direction. Okay? Now, next question is, Abdul, while driving to the school, computes the average speed for his trip to be 20 kilometers per hour. Okay? This probably what we'll do is, we'll make it a last question, and all the other questions we will discuss in the next class. Okay, so this is the last question that we are discussing. Abdul, while driving to school, what is the average, what is the speed when he travels from home to school? 20 kilometers per hour. Okay, and he's coming back from school with what velocity? 30 kilometers per hour. Now you have to calculate the average speed of Abdul's trip. Okay, you have to calculate the average speed. He goes at 20 and he comes back at 30. So what is the average speed? Now here you don't know anything. You don't know what is the distance, right? So what you will do is, you will consider the distance to be d. So let's say the distance is d. Okay, so if we have to calculate average speed, what is the formula? Total distance upon total time. So just remember this formula. We will come back in a while on this formula. Okay, so what we are going to do is, now look at this, the time taken to go to the school. If first calculate the time taken to go to the school. So we know the simple formula of speed is equal to distance upon time. This is a normal formula without any acceleration. Speed is equal to distance upon time. So from this formula, calculate what is time. Time is going to be distance upon speed. So t is equal to d upon 20 is going to be the time taken to go to the school, right? What is the time taken to go to the school? Time taken to go to the school is d upon 20. Now, same way, calculate the time taken to come back from the school. To come back from the school, it will be distance upon speed. So what is the distance? We have considered the distance to be d, and what is the speed while coming back? It is 30. So we have now calculated two times. One is the time that he takes to go back to the school, and the time that he takes to come back from the school. Okay, now we have this is the formula that we studied. Average speed is total time upon total distance. So now we have calculated the time. What is the total time? Total time is going to be both t1 and this both the t's you have to add. If you add both the t's, look at this, what it becomes. It becomes d upon 20 plus d upon 30, which will, if you solve this, you will get d upon 12. So this is the total time we have calculated. So we are going to substitute total time as d upon 12. What about the total distance? What is the total distance? Look at this, he goes to the school. What distance does he travel? D. He comes back from the school. What distance is he traveling? Again D. So what is the total distance? The total distance is going to be d plus d, which is 2d, right? So now just substitute the form all these values. 2d will be the total distance and d upon 12 is going to be the total time. If you solve it, you will get 24 kilometers per hour. So this is the average velocity. So when someone goes at 20 and comes back at 30, the average speed is going to be 24 kilometers per hour. So we can change these figures and give you similar, ask you to solve similar questions. So remember, in these types of questions, first calculate what is the time taken to go to the school, okay, and the time taken to come back from the school. How will you calculate the time taken? You do not know your distance, so you will consider your distance to be d and then try and solve the these numericals. Okay, so I think we are done for the day. All of you should practice all these questions in your any of your rough notebooks and start doing the exercise questions in your homework copies. The leftover questions, we will be doing it in the next video session. So that's all for today. In case you have any doubts, I'm here for next few minutes. You can write your queries in the chat box so that I'll be able to answer you. And all of you, please put down your attendance. So that's all for the day. Thank you so much. We will be meeting in our next video session.